All right, so we are starting off Unit 3 today, and we're going to be starting off with the rate of change in slope. Some of this is going to be review. I believe most of this lesson is review from grade 9, so bear with me either way. But the first thing that we have to do is we're going to be just looking at graphing review. So just a couple things to remember from previous years. Whenever we talk about rate of change is going to be one thing and slope is the other. They're both essentially the same as each other. We are always looking at rise over run. Rise is your y-axis, run is your x-axis. So the first thing that we look at is what the x-axis and y-axis are. Remember, we are talking about the Cartesian plane, which often looks like this. Our x-axis is the horizontal one, and our y-axis is the vertical one. So for instance, this is our y-axis, this is our x-axis. The ordered pair is a pair of numbers. They're listed in x value first, then y value. Easy way to remember this is it's alphabetical. So for instance, if I wrote 2 and 4, I would say 2 on my x-axis, 4 on my y-axis, find where they meet, and that is my ordered pair point. The origin is the point where the x and y-axis meet, which is represented by the ordered pair 0, 0. So it is essentially, if I look at this graph down here, right there is our origin. Awesome. And then we're going to do one example just to refresh our memories from grade 9, and then we're going to move on to some linear systems. So whenever I write an ordered pair, essentially all I'm doing is putting a bracket here, and a comma in the middle. So the first one would be -2, -3. The second one would be -1, -1. Third one would be 0, 1. Fourth one would be 1, 3. And the fifth one would be 2, 5. Now I have to actually plot those points on the graph. When we say plot, we just need to graph them, put them on the graph that you have. So to start off with, I'm going to go to -2 and -3. I'm going to find where they connect, which is right here. Then I'm going to go -1, -1. Those connect right there. Then I'm going to go 0, 1. Those connect right there. Then I'm going to go 1, 3. Those connect right there. And then I'm going to go 2, 5. Those connect right there. And now I've plotted all 5 points. Awesome. So now if I move on and I take a look at the next section that we have, we're going to be moving on to linear relations. So the first thing to remember is what a linear relation is. This is anything that appears as a straight line. So this would be a linear relation. We say that it is linear. When we refer to a line in general, we are not always saying that it's a straight line. We're just saying that we have a line that's drawn. You can have a curvy line, you can have a wavy line. In this case, we are looking specifically for a line that is linear and dead straight with no curve to it whatsoever. Whereas a non-linear relation does not appear as a straight line. And I apparently did not leave myself enough room there, but that is okay. So that would be something like, which is non-linear. The rate of change is just a change in one quantity relative to the change in another quantity. So when I'm talking about the fact that I am driving 50 kilometers per hour, 100 kilometers per hour, 80 kilometers per hour, whatever speed I'm driving at, I'm talking about the change in the distance that I go relative to the change in the time that has passed. If I talk about how much money I make per hour, I'm talking about the change in dollars per the change in hours that I'm working. So the first thing that we're going to do is we're going to take a look at this table, and we are going to look at the rate of change in the distance specifically here. So when we do this, we're going to use something called first differences. What that means is I have these two values and I want to know the difference between them. So when I'm doing this, I'm going to go 55 minus 0 is equal to 55. If I take a look between these two numbers, that one goes there, this one will go here. I have 110 minus 55 is also equal to 55. If I take a look here, I have 165 minus 110 is equal to 55. And last but not least, I have 220 minus 165 is also 55. So what does the rate of change represent in this case? And another way that we can typically draw this out just to help us answer the next question is I always draw little triangles between these two numbers so I know which ones I'm comparing. Here there is a 1 hour change in time. Here there is a 1 hour change in time, 1 hour and 1 hour, because I go from 0 hours to 1 hour, 1 hour to 2 hours, 2 hours to 3 hours, and 3 hours to 4 hours. What this means is that for every hour I drive, I go 55 kilometers. So if I say I'm driving 100 kilometers per hour, that means in 1 hour I can drive 100 kilometers as long as I don't change my speed. But that is just going to be looking at a rate of change. Now we're just going to move on to another example where we're going to graph the time versus distance from the table on the grid below, which was supposed to be that table right there. I don't know why it says below. Bear with me on that one. Okay, so when we take a look at this one, we know that at time 0, I had not gone any distance. And this is one where you might want to look up a little bit. What I'm actually going to do is write out my ordered pairs to make it easier. Awesome. Now that I have those there, my first point was right here. At time 0, I went 0 kilometers. At time 1, I went 55 kilometers. So it's roughly just above the 50. At time 2, I went 110. So it's a little bit more past that. At 3 hours, I went 165. And at 4 hours, I went 220. If I look, I can connect those with a line. My line stops jumping around. And I'm just going to add an arrow to either end of it. Now, if a car had a different speed of 75 kilometers, how would the graph of this car's distance versus time differ from the first car, and how would it be the same? So the first thing that I'm going to do in this case is I'm going to end up drawing it out on the graph when we can. You will get used to being able to describe the differences without actually seeing the graph. But just to start off with, we will do that. So if we're going 75 kilometers per hour, that means I'm just going to write this one was 55 kilometers per hour. That means at 0 hours into my drive, I've gone 0 kilometers. I'm still parked in my driveway. After the first hour, I should be able to have gone 75 kilometers because my speed hasn't changed. After the second hour, I'm going to add another 75 to that. So now I should be at 150. If I go another hour, that should bring me to that should be about a quarter of the way through, 225. And if I go another hour, that should bring me to 300. So if I also graph that, now I can take a look at the two graphs. What I can see is that 75 kilometers, I'm just going to zoom this in so I'm not writing so small, per hour has a steeper graph. The rate of change is bigger. I'm going more kilometers in the same amount of time. Something that is similar about them, though, is that they both start at the origin because they both start at 0, 0. Awesome. So if we take a look at the next one, we are going to complete this graph or complete the following table of values using the equation. So we have the equation y equals x plus 3. We're going to assume there is a 1 here and then graph the relation. So we're going to draw a line through all of our points, and we typically just place arrowheads at either end. So what this means is I have my x value, but I don't have my y value. If I substitute my x value into my equation, though, then I can figure it out. So all I'm going to do here is that my y value is -2 because that's my x value plus 3 because the equation says x plus 3. That should give me a value of 1. If I look at -1, now it's -1 plus 3, which should give me a value of 2. 0 plus 3 will give me a value of 3. 1 plus 3 will give me a value of 4, and 2 plus 3 will give me a value of 5. Essentially, I'm just going to write that out on the side so you can see what I did. We had a y equals x plus 3, so it would be like y equals -2 plus 3, etc., all the way down. Now I'm going to look at my rate of change. If I look here, I have 2 minus 1 equals 1. Here I have 3 minus 2 equals 1. Here I have 4 minus 3 equals 1. And here I have 5 minus 4 equals 1. So I know my rate of change in my output, which is my y value, is 1. If you took a look at the rate of change in your x value, it would also be 1 because we go -2 to -1, which is 1 jump, -1 to 0, which is 1 jump, 0 to 1, which is 1 jump, and 1 to 2, which is 1 jump. Now, if I plot those points, I know that at -2, I've gone, -2, I've gone a y value of 1. So I'm going to be right here. If I go to -1, I have a y value of 2. If I go to 0, I have a y value of 3. If I go to 1, I have a y value of 4. And if I go to 2, I have a y value of 5. I'm then just going to plot those points, but once my line is cooperating, and put an arrow on both sides. So then, is this relation linear or nonlinear? We can see that it's a straight line, so that is linear. We're going to do this one more time. Now I've got, or I don't think it's one more time. I think it's a few more times, but anyways, this should be 3 times -2 plus 1. 3 times -2 is going to give me -6 plus 1, which is going to give me -5. If I do 3 times -1, I get -3 plus 1 is going to give me -2. If I do 3 times 0, that gives me 0, plus 1 is going to give me 1. If I do 1 times 3, that gives me 3, plus 1 is 4. And if I do 2 times 3, that gives me 6, plus 1 is 7. So now if I look at the rate of change, I have -2 minus -5, which gives me 3. I have -2 minus -1 gives me, 1 minus -2 gives me 3. This is -2 minus -5. This is 1 minus -2. This is 4 minus 1. And this is 7 minus 4. That gives me 3. And that also gives me 3. So I know my rate of change here is 3. One thing I would like you to keep in mind now is what we're noticing that might be similar about the equations given to us and the rate of change that we see. You might remember where I'm going with this based on grade 9, but we'll see once we get to there. I now graph these at an x value of -2. I have a y value of -5. So my line's going to be down here. At an x value of -1, I have a y value of -2. At an x value of 0, I have a y value of 1. At an x value of 1, I have a y value of 4. And at an x value of 2, I have a y value of 7. That line is surprisingly going to meet all my points. And I'm just going to add my arrowheads to either side. We can see that this is also linear. Essentially what it's saying is for every one that the x value increases, the y value increases by 3. So for every 1 over, which is our run, I'm going to go up 3, which is my rise. Now, if we look at this one here, I have to complete the following table of values using the equation y equals x squared and then graph the relationship. So all I'm going to do in this case, it's going to be y is equal to x squared. So it's equal to -2 squared. So we know all these values are going to be positive because I have a negative times a negative, but -2 squared is going to give me 4. Negative 1 squared is going to give me 1. 0 squared is going to give me 0. 1 squared is going to give me 2, and 2 squared is going to give me 4. Nope, 1 squared is going to give me maybe. Sorry about that. 0 squared is going to give me, 0. 1 squared is going to give me 1, and 2 squared is going to give me 4. So now if I look at the difference between these, I have 1 minus 4 is negative 3. 0 minus 1 is negative 1. 1 minus 0 is 1. And 4 minus 1 is 3. Notice that these are not the same value. So now if I graph those, I'm going to get negative 2 gives me 4. Negative 1 gives me 1. 0 gives me 0. 1 gives me 1. And 2 gives me 4. If I draw a line through these so that I hit every single point, this is non-linear. There is a curve to this line, so it's non-linear. So linear relations are going to be anything that has a constant slope. If the slope is the same at every single point, it is constant. Now, did want to ask a question? Obviously, no one can answer. What I'm hoping everyone was able to pick up on is the fact that the rate of change and the value right here in our equation are the same. So the rate of change is equal to the value in front of x. Awesome. And that is everything for this unit. The one thing I do want you to complete is this Desmos activity. I will link it in D2L so that you have it there to go over. This is going to be completion based only. So if you do, I want to say there's 7 or 8 activities in it. You do all 7 of them, you get 7 out of 7. I'm not going to take a look at them to see if you got them right or wrong. It's just for your practice, but I'll add it into your marks as a little bit of a buffer there. Awesome.